All right, so in this problem, we have an athlete that is 2 kilometers offshore. So let's assume that the athlete is right here and then the shore is over here. And this distance is 2 kilometers. And he needs to reach a finish line that's 8 kilometers down the shore over here. So this distance is going to be 8. And he can row at a speed of 6 kilometers per hour. And he can run at a speed of 10 kilometers per hour. And we need to find the least amount of time it will take for him to reach this point over here. So we know that the ideal path would be for him to go diagonally till the shore and then a run the rest of the way. So he has 2 trips on this journey, the boat trip right there, which is the hypotenuse, and this on the land, which is basically an extra distance that he's going to run. I'm going to start by just labeling this as x. And if this is x, this distance over here will be 8 minus x. Next, I'm going to find my hypotenuse using Pythagorean theorem. So c squared equals x squared plus 2 squared. C squared equals x squared plus 4. So c is just x squared plus 4 to the power of 1 over 2. So now I want to minimize the time. So I'm going to do my time equation. So time equals to the time it takes for him to row, which I'm going to call T1, and then the time it takes for him to run, which is T2. And I want to minimize this time, so I'm going to end up deriving this time equation. T1, so remember, we have our formula for speed, distance, and time, and we know that time is just distance divided by speed. So time 1 is just distance 1 divided by speed 1, and distance 1 is just c, which is x squared plus 4 to the power of half. And my speed over here is the speed at which he rows, which is 6 kilometers per hour. My distance, my time 2 is my distance 2, which is just 8 minus x, divided by my time 2, or my speed 2, which is basically 10. That's the speed on land. Now that I have my time equation, all I have to do is derive this and solve for x, and I'll get my solution. So t equals, I'm going to simplify this before deriving it, just to make it a bit easier. I'm going to split my denominator here. So plus 8 over 10 minus x over 10. And now it's going to be much easier to derive. So let's derive this. So t prime equals 1 over 2 x squared plus 4 to the negative 1 over 2. This is all divided by 6. And then by the chain rule, I'm going to multiply by 2x. And then over here, this constant disappears, and the derivation of negative x over 10 is just negative 1 over 10. So now we just need to make this equation equal to 0 and solve it. I'm going to turn this into 0. Over here, I'm just going to cross off these 2's. So on the top, I just have an x. I'm going to move this term to the bottom. It's going to be 6 x squared plus 4 to the power of 1 over 2 minus 1 over 10. I move the negative 1 over 10 to the other side. It's going to become positive. I'll cross multiply both sides. So 6x squared plus 4 to the power of half equals 10x. Divide the 6 on the other side. So 10 divided by 6 is 5 over 3. Then I'll square both sides to get rid of this. So I have x squared plus 4 equals 5 over 3 squared is just 25 over 9, 25 over 9x squared. I'll subtract the x squared on this side. So that's just 16 over 9 x squared. We'll multiply the 9 to the other side, so that's 36 equals 16x squared. I will divide both sides by 16. So 9 over 4 equals to x squared. And then I'll square root both sides, and I'll just get x equals 3 over 2. I don't have to worry about the negative solution here because the only possible solution is a positive one. So basically the 3 over 2 we know is 1.5. So we know that he should land his boat 1.5 kilometers away from this part over here, or basically 6.5 kilometers away from the finish line of this race. And that will minimize his time. And if you want to find the actual minimum time, you can also sub in the x value of 1.5 into the time equation. So I'll do that really quick right now. 1.5 squared plus 4 to the power of half over 6 plus 8 over 10 minus 1.5 over 10. And that minimum time will be 1.067 hours. So that's the actual minimum time, and x is the distance 1.5 kilometers away from basically this part over here, the in line with the island, or 6.5 kilometers away from the finish line.